I'm in a little hurry for that exhibition thing. We'll see whatever part is completed till that time. We will not wait for latecomers. Let's start. We still have 30 students. Okay, a good number. We are working with chain drive. Today we are going to design chain drive using PSG design data book. Other day we designed it using Shivalka design data book, where you have the formula for the power transmission capacity for the chain given directly. In PSG design data book, the procedure is different. So we'll see how the procedure varies, and it is entirely different rather. When we are working with PSG design data book, we check for two different criteria of design. And the criteria are: what is the braking load coming on the chain, and what is its bearing strength. Do you remember how a chain fails? What is the criteria for failure of chain? Nandana? Elongation. Yes. So this is decrease in the diameter of the pin. So it is essentially the bearing pressure on the pin which exceeds and its strength goes down, or the pin undergoes wear and tear, its cross section reduces. So we have to be very careful with the bearing strength. Braking load will fail the chain, but this rarely fails because the factor of safety is very high. It could be 7, 8, 10, 11, 12. And so we will check for the braking load, but we'll only see that the factor of safety is greater than the required factor of safety range that is given in the design data book. And we have to, using the graphs, we have seen how we tentatively select the type of chain. And from the type of chain, hash 50, hash 40 that we select from the graphs, we get what is the pitch, and we also get the number of teeth, T1 on the smaller sprocket. Now, as you go on increasing the number of teeth, the diameter also increases, diameter of the sprocket. As the diameter of the sprocket increases, the allowable bore diameter is the diameter where the shaft would be placed. So the shaft diameter or the bore diameter, this also increases. If you go for a lesser number of teeth or a smaller number of teeth, whenever you are stuck up with graph wherein you are getting number of teeth either as 19 or 21. So if you select 21, then the diameter of the sprocket is also larger, and this is definitely greater than the bore diameter. That you have to ensure. If you select the lower number of teeth, then the diameter of sprocket also goes down, and the bore diameter has to be again smaller than this, which means the permissible bore diameter, the diameter of the bore that is permissible, this becomes a function of number of teeth. And so you have to be careful while selecting how many number of teeth you are selecting. And as I said, when we work with the selections, we have to be also careful with the pitch. If the value of pitch that you are selecting is small, and if the pitch diameter of the sprocket is large, this combination is good. This combination is good But for the smaller value of pitch, the rated power value goes down. We have seen that this is ultimately depending upon the pitch, and from the Shivalka data book we have seen that the power transmission capacity is proportional to square of the pitch. But if you increase the value of pitch, just because you want to increase the value of PR, the value of pitch diameter of sprocket, this also increases. With the increase in the pitch diameter, the peripheral velocity increases. With the increase in the peripheral velocity, the chordal action increases, the centrifugal tension increases, and these two components, they are undesirable, and which leads to decrease in the power transmission capacity. I am just writing in terms of numbers. You have to make it statements. So we have to be very careful with selection of pitch. You cannot randomly increase the value of pitch, or you cannot decrease the value of pitch. And hence proper selection is very important. So how do we check for the strengths is using the first criteria, which is the breaking load. We will find the value of breaking load in the design data book that is given in the PSG data book. And this breaking load will be equal to the FT or the T1 tension that we talk about, which is the tight side tension of the chain. Then this is equal to chordal action. Then this is equal to centrifugal tension. So these three values, their sum, this should not exceed the breaking load. If this exceeds the breaking load, then the chain would fail. If this value exceeds the breaking load capacity, then the chain would fail. But this doesn't happen, and the reason is the factor of safety is very high, of the order of 7, 10, 11, 12, 15. So this is the factor of safety. So what we are going to check here while designing is the value of breaking load is given for a given pitch and for the given chain in the design data book. We'll calculate what is FT, FCH and FC. We will take the ratio of this, which will give us the factor of safety. And when we are checking for the bearing pressure, now this bearing pressure is the bearing strength of the pin. Bearing pressure or the bearing strength of the pin. And this is the load, that is FT. For the pin, this chordal action or centrifugal tension, these two components, they are not responsible for loading the pin. So pin is loaded only because of the tight side tension of the pin or tight side tension of the belt upon the bearing area A. Bearing area of the pin. This we have to check. The bearing strength is given in the data book. We have to make sure that our strength is coming out to be greater than the permissible value. And the bearing area for the pin is, if this is the pin, if I take its cross section, this is its bearing area. And this is again given in the design data book. So we are going to check for these two values. If this value is saved, and the selection that we have done, that is also saved. So these two checks you can do only using PSG design data book. This is not given in the Shivalka data book. But the problem is the graphs which are used for tentative selection, those graphs are not given in the PSG data book. So you have to refer both the design data book for this kind of problem. And for lubrication, we have to suggest the kind of lubrication also. So for lubrication, there are more curves which are given in, which are not given in both these data books. So I'll be supplying you those graphs. So based on the power and the RPM, the kind of lubrication is given, and we get the graphs of this type. I have shared one such graph in the WhatsApp group. These are the bold lines. Class 1 lubrication, class 2 lubrication, and class 3 lubrication. These are demarcated using this. If here this is indicating increase in the RPM, power is mentioned, the power transmission capacity is mentioned in these boxes or in these cells. The number of teeth goes down, number of pitch goes down as you move vertically downwards. If your power, number of teeth and RPM lie in this range, then you are in class 1 category of lubrication. This is class 2 category of lubrication. And this is class 3 category of lubrication. So this, let us solve the problem and we get to know how this problem is done. Let us solve the same problem that we solved the other day. The same problem we'll solve now using PSD design data book. Keep both the design data books handy with you. We have a 1000 RPM motor. We are solving the same problem to check how the answer varies. Transmitting 7.5 horsepower to a compressor shaft. I'll be going a bit fast. If you have any doubts, please feel free to ask. 350 RPM. So the two sprockets, they are rotating at 1000 RPM and 350 RPM. The power to be transmitted is 7.5 HP. The compressor shaft is running for 12 hours per day. We have to select the appropriate chain. Now, number of factors are given in the design data book here, and those factors will multiply later. So initially we are selecting the chain based on the rated power. Here we are not multiplying it with the service factor initially. This part will do later. So we are selecting the chain based on the rated power 7.5 HP. So refer the graphs that are given in the Shivalkar design data book. For 7.5 HP power, for 1000 RPM, for the smaller sprocket, which chain you will select? Quickly, please. For the chain to fail, braking load should be less than the summation. Okay, page number for selection of chain is Shivalkar design data book, page 152. Shivalkar design data book, page 152. Yeah, I'm coming to it regarding the braking load thing. .5 HP, 1000 RPM. Ash 50 chain. Number of teeth. Number of teeth 19 or 21. You want to go with 19? Okay. So number of teeth on the smaller sprocket is 15 and pitch is 5/8 of an inch, which is how much in mm? It's given on the same page in the table below. Value of pitch 15.875 mm. Now this hash 50 in the PSD design data book, it is indicated as R50 chain. Check for R50 chain pitch 15.875 in PSD design data book. The table will give us what is the braking load for R50 chain, this is page number 7.72 as per my book. R50 chain. R is roll-on for the single strand. R50 pitch 15.875. Got it? What is the breaking load? Right. Sorry, 15 is a 19. Yeah, so breaking load is given as in kgf. Convert this into newtons. In newtons, assuming G as 10, 22.2 kilonewton, right? And what is the bearing area given? This is bearing area of the pin. Breaking load is for the chain. It is 0.7 units centimeter square. Will need to be converted into millimeter square. Okay. Number of teeth we have selected as 19. Let's see as per this design data book if this is correct. What is the velocity ratio? N1 by N2 here. 1000 by 350. What is the velocity ratio coming out to be? Atharva? 2.5. 2.85 or 2.58? 1000 by 350 exact is 2.85. Okay. Turn the pages. You have hard copy. This is giving you the minimum number of teeth on the sprocket, the range depending upon what is the transmission ratio or what is the velocity ratio. This is given on page number 7.74. If the velocity ratio is in the range of 2 to 3, our value is 2.85. What should be the number of teeth on this sprocket? This is on the smaller sprocket. 25 to 27. So number of teeth T1 should be in a range of 27 to 25. Now what is the limit? Why can't we use 19 or why can't we go for a lesser value or 21 say? So when you are selecting the number of teeth, the limitation is the hub diameter or the shaft diameter. With number of teeth 19 here, the diameter of the sprocket becomes too small and the hub diameter or the bore diameter would be sufficiently large. Because you cannot have a shaft which is very thin, which it cannot be like a pin. And in the Shivalkar design data book, we check the diameter and that is coming out to be greater there. But here we are not checking it that way. So we are checking for given velocity ratio, what is the number of teeth on the sprocket. Similarly, for the larger sprocket, there is an upper limit. You cannot have a very large sprocket because then the size of the entire assembly would become too big. And so on the lower side, the limit is the bore diameter. On the upper side, the limit is the space constraint or the space availability. And so let's go with some value between this. We have to select an odd number. So let us take it 25. So what is T2? Number of teeth on the larger sprocket. This into 2.85. Number of teeth should ideally be odd numbers. With the experimentation, they have seen that with odd number of teeth on the sprocket, the wear is low. So what is the number of teeth on the larger sprocket? 71.25. So we'll have to go with 71 or 73. Because we want odd number. We cannot have 72. We want odd number. So with the larger number of teeth if you go, then the size or the diameter increases. So let's go with 71.25. If this comes out to be 71.85, 71.9, then we better go with 73. Then the center distance. Center distance, as you understand, we always take in the range of 30p to 50p, and let us safely go with 40p. On the lower side, the constraint for a smaller center distance is the sprockets become too close to each other. If you take too large a center distance, then the chain would start sagging. And so we take a value around 40p every time. Let us check what is the maximum permissible load. So the permissible load we have taken is the 22.2 kilonewton. This is the, for R50 at this load it will break, and we have to make sure that the total load coming on the chain is less than this permissible load. So total load is, this is given on page number, turn your pages, 7.78 PSG design data book. PT is given instead of FT. The load, the tangential load because of the rotation of the chain, plus the centrifugal tension, FC or PC. And instead of caudal action, this is talking about the tension in the chain because of the sagging of the chain. Sagging component is larger here because it is metallic and the weight is sufficiently large. So this is the sagging component. PT is same as FT, and then this will be multiplied with the service conditions now. K1, K2, K3, K4, and there are almost till K6 the service conditions are given. We'll take all of them one by one. The value of PT is same as FT, which is rated power upon peripheral velocity. We are not taking design power because we are multiplying with this K1, K2, K3 later on. So we are taking it as rated power upon VP. Rated power, you know, convert 7.5 HP to kilowatt, and this is pi D1 N1 by 60. And how do you find out the diameter of the sprocket? Diameter of the sprocket, excuse me please, hello, hello, P upon sine 180 by T. T1. Give me diameter, give me peripheral velocity, and so give me what is this tension on the chain. Give me all the values quickly, please. The centrifugal tension, PC, what we call as FC or TC. This is giving you the formula. Weight per unit length of the chain, again given in the design data book by G. Give me what is the weight per unit length of the chain given in the design data book. FT is coming out to be 1130. Please give me what is VP first. Give me the value of BP and the diameter also. Is that 6.6? Others, please confirm. 6.6. Okay, and so what is PT? One one three zero. Give me in kilowatt. Give me in kilowatts, please. Convert the rated power from HP to kilowatt. This would be around 5.5 kilowatt. Answers quickly, please. Come on, Saurabh, Pradyuman. 0.84. Yes. Yeah, this is in Newton. 840 Newton. This is correct. 844 Newton. Weight of the chain per unit length for R50. This is given. Weight per meter. What is the value? What is the value for weight per meter? 1.01 kgf per meter. Assuming it 10, so it is 10 Newton per meter. So look, this is the weight, almost 1 kg for 1 meter length of the chain. Vp you know, value of G you know. Give me what is the value of centrifugal tension and what is the tension because of sagging. So sagging depends upon the coefficient of sag K. The design data book. Weight is given in the design data book on the same table where you got the braking load and the bearing area. Weight is given. So assuming horizontal, the value of K becomes 6. Depending upon the angle, this sag would vary. W is the weight per unit distance and C is the center distance. Center distance, we have taken 40 times pitch. 44 and 45, this is PC, right? Atharva, this is PC. Okay, and PS, K into W into A. So K is the factor for sagging. For vertical, the coefficient of sag is 1. For horizontal, it is maximum. The value comes 6. W is this weight, 10 newtons. A is the center distance, which we have taken as 40p. This is A here. As the center distance increases, this coefficient of sag increases, and this adds to the braking load. And that limits the center distance. You cannot have a center distance very large. Give me this in newtons. 6.3. It's too small. This is weight per unit meter, Newton per meter. Convert the center distance in meters. P, 40p. It's in millimeters. 38 is correct. So now the total load is sum of these three multiplied with all the factors. So this comes out to be 844 plus 45 plus 38. Again turn the pages, come to page number 7.76. The service factor depends upon 6 different factors. First one is the load factor, second is the factor for distance regulation, third is the factor for center distance, next is the factor for position of the sprocket, then the lubrication factor, then the rating factor. So there are so many factors. If nothing is given, then we assume everything as the load factor is constant load, or if you want, you can consider the load with mild shocks or load with heavy shocks. If I consider load with mild shocks, my value of K1 comes out to be how much? For load with mild shock, assuming compressor is creating mild shock, what is K1? 1.25. Next is the factor for distance regulation. Either we are having adjustable supports or the drive with the idler sprocket or the fixed center distance. Now if nothing is mentioned, we assume this is having adjustable support, or this is the simplest of condition with K value as 1. Factor for center of distance. If your center distance is less than 25 p, in the range of 30 to 50 p, or if it is greater than 60 to 80 p. So what is this value for K3 based upon our center distance? It is 1. Next is factor for the position of the sprocket, whether it is horizontal or inclined, and what is the angle. So if nothing is mentioned, we assume this is horizontal with the value of K as 1. So you have to mention assuming horizontal position, K4 is 1. Assuming center distance 40 p, value of K is 1. Likewise. Lubrication factor. As of now, we don't know what is the class of lubrication. Let's go with drop lubrication, that is class 2 lubrication. So again, the value of K is 1. And the rating factor depending upon how many hours it is working, 8 hours, 16 hours, or continuous running. Hours is working for 12 hours, it should lie somewhere between 1 and 1.25. So let us go with 1.25 on the higher side. Yeah, so now give me what is this total load. This is the total load. Give me the value, please. Is that 1448 Newton? Okay. What is the braking load? 22.2 kilonewton, which means what is the factor of safety we are having? The allowable braking load is 20.2 kilonewton and this is 1.448. So this is the factor of safety, and the range of factor of safety is also given on page number 7.77. For the sprocket with pitch 15.875 and the speed of the smaller sprocket as 1000 rpm, the range for factor of safety is given. Give me this value first. What is this by calculation? 22.2 upon 1.44. This is the factor of safety by calculation. 15.41. Good. Or 15.3. And what is the range of factor of safety? Minimum value of factor of safety as given in the design data book is how much? Page 7.77. Minimum value of factor of safety for pitch 15.8, for smaller sprocket rotating at 1000 rpm. The minimum value of factor of safety is 11 and our factor of safety is greater than 11, which means this is very safe under breaking load. That is the reason a chain will rarely fracture. A chain will rarely fail. So it doesn't fail because of load, because since the factor of safety is very high. So what is the other reason of failure is the pin. So we have to see what is the load on the pin. The second criteria we are checking for. This is by design that the factor of safety for the sprocket and chain is always taken in this order, in the order that is given in the design data book, in the range of 7 to 18. Failure of chain when it is running at a very high, when it is running at a high RPM, if it fails because of the centrifugal tension, from the safety perspective, the factor of safety is kept very high. Yeah, it is because it is metallic. It is metallic. Since it is metallic, the weight of the chain is high. Since the weight of the chain is high, if it fails, it will be thrown away. The links would be thrown away at a very high speed. And this cannot be accepted. And so the standard manuals, they say that this factor of safety has to be very high. Now load on the pin, the load on the pin is this tensile load Ft or Pt that we have calculated. So that load is finally taken by the pin multiplied by the same service factors K1, K2 till K6, 1.25 into 1 into 1 into 1 upon the bearing area, which is how much? 0.7 centimeter square converted into millimeter square. Give me this value. We also have the value of allowable bearing stress given in the data book. So this is load up on the pin upon the bearing area, which is giving us the allowable bearing stress. Bearing stress on the pin. Load on the pin upon the bearing area. Load on the pin is this Ft, the tension in the chain, which is transferred to the pin, multiplied by all these service factors again upon the bearing area, which is given in the design data book. This bearing stress is 18. Okay, units. Newton per mm square. Okay. Same page below the minimum value of factor of safety. What is the value of allowable bearing stress? Allowable bearing stress. Give me the value in Newton per mm square. This is in kgf per mm square. If we simply multiply, this is 22.4 Newton per mm square. So our value is less than this allowable bearing stress, which means this is, even the pin is safe. Pin is safe. This has given us chain is safe, which means our selection is correct. So it is hash 50 chain or R50 chain that we have selected. You have to again calculate the length of the chain. So we have selected R50 chain or hash 50 chain with pitch as 15.875 with the two sprockets, the smaller sprocket having 25 teeth, larger sprocket having 71 teeth, and length of the chain in terms of pitches What is given in Newton per mm square? Atharva?
Allowable bearing stress is Newton per
What is the
mm,
value given?
2.24.
No, my design data book is giving the value in kgf per mm square. I thought you are having a higher version with Newton per mm square. Sarthak, Prajwal, what is the unit given in the PSG design data book for allowable bearing stress? Vaishnavi, in your design data book, is that Newton per mm square given? Please correct it. If it is 2.24, it is in kgf per mm square. And if it is in Newton per mm square, the value should be 22.4. And length of the sprocket, this, yes, you can calculate. Lubrication, quickly please. 2 minutes and then we have to stop. The type of lubrication, I have posted a graph on your WhatsApp, machine design WhatsApp group. Check for the RPM of the sprocket. Check for the power as based on the number of teeth. This is again the power is given in HP for 1000 RPM and for 7.5 HP power. I'm sorry, the Xerox that I'm carrying is not complete. So आपको number of teeth नहीं दिख रहे होंगे on the left side. Can you suggest the type of lubrication from the graph? For 1000 RPM and for 7.5 HP. The numbers written in the graph. What is 8.9? What is 8.9? Type 2. So it is type 2 lubrication. This you must mention. So for different value of pitch, the type of lubrication is given. And this is important to mention what type of lubrication is there. If you have any questions, please feel free to post on the group. I'm closing this meeting today since I have some other appointment now. Thank you so much. Your attendance is taken. Feel free to ask questions related to this on the group. We are finished with this chain drive. Next class we are going to start with the flywheel design. Thank you one and all. Hello.